Okay. You guys hear me okay? So, good afternoon, everybody, and welcome back after lunch. This is the second presentation in the FHIR in the Cloud track. My name is Hansen, and I'm with Microsoft Healthcare. I've also been asked to introduce my friend here, Dr. Firecat. In case you can't tell, it's the Octocat wearing a doctor's coat and a fire helmet. No Google socks, though. But that's we have made some stickers of this guy. You can come pick it up out at our table. We have plenty of stickers, trust me. So come pick up one of those afterwards when you come chat with us. So since this is a developer conference, in this presentation I want to focus on the experience of developing and deploying FHIR applications and scenarios in the cloud. And I want to focus on the Microsoft FHIR server for Azure that we released this week in open source. It's available on this at this GitHub location, and you can go deploy it right now, and I'll also show you how to do that a little bit later on. But more generally, though, I want to focus on this idea of deploying open source or innovative applications onto a managed cloud platform and what that can provide you with. So I think most of the people in the room here are focused on developing new applications, delivering new value to patients and customers, and they don't really care too much about managing the underlying platform that you deploy this on. But that's of course very important as you move from prototyping and into production. And managed services in the cloud can really help you a lot with that. So just to kind of set the stage and explain what I mean by that, this is a slightly overwhelming slide, apologies for that, but these are some of the services that we have available in Azure. And what I want to point out here is that when a lot of organizations move to the cloud, they're really leveraging initially these sorts of infrastructure services. So these would be virtual machines and storage and networking and so on. And we have those, of course. And while I think that we do those as well as the next company, I think the real value of being in the cloud is actually when you move upwards in the slides and start leveraging some of the managed services that we have available in the cloud. So I want to touch on some of those and how you can use them when you deploy FHIR applications in the cloud. So a few of them that I'll be mentioning in this presentation. So app services for hosting code, managed databases, Azure Active Directory for identity, API management is obvious for FHIR APIs, but also things, tools that orchestrate the movement of data, such as Data Factory and other tools. And I'll kind of try to illustrate how you can put together entire applications using this. And why is this important? And Kurt from Google mentioned this a little bit earlier on, had a similar slide, but as you move to the cloud and want to do things in the cloud, you could do this in many ways. You could actually build your own cloud, right? You could just have a data center and put a bunch of computers in there. And there could be good reasons to do that, but then you take responsibility for everything. Every hard drive that breaks and so on is now your responsibility. Either you have to fix it when it breaks, or somebody has to be working for you that do that. And then if you use these infrastructure as a service offerings, so virtual machines and so on, it's certainly a step up because you're no longer managing hardware, but you still install an operating system and a runtime on that, and you're now responsible for patching that and managing that, and that could become a big liability when you move to production. So platform as a service is a much nicer place to be if you can run all your stuff in that, because now we install the operating system, we patch it, and we keep everything up to date. And but you bring the important stuff, right? The code, the application, and the data, which is where the value really is. And you can focus on that piece of it. Software as a service is things like webmail and so on, which I won't be getting into here. So let's say now I wanted to run some FHIR stuff in Azure. Then you need a place to host some code, and we have something called Azure App Service, and that's our managed app hosting platform where we provide a number of runtimes where you can just deliver your code. So if it's written in .NET, Node, Java, Python, whatever it might be, you bring your code, and we manage the platform for you. So it's managed in the sense, as I said, that we patch it, but also other tools are available, auto-scaling, backup and recovery, and so on, that you will need when you want to run things in production. It's available globally in many data centers, and you can leverage things such as Azure Active Directory for identity and all the compliance work and so on that we do on this platform. So you actually get quite a lot out of that if you just deliver your code into this. So that's somewhere to run your code. Then you also need somewhere to store some data, and you need a database. Again, you could set up a virtual machine, you can install a database server on there, and you can put your data into that. But in the cloud, you can also just get a database. And so since we're Microsoft, we of course have Azure SQL Server or SQL Database. Oops, I should go back again here. Azure SQL Database, which is our managed SQL Server in the cloud. But we also have open source ones like MySQL and Postgres and so on. And we have Cosmos DB, which I will return to in the next slide. And in addition to these sort of transactional databases, there's data warehousing tools, big data processing, Hadoop, Spark, Data Lake, and other things that link into visualization tools like Power BI, where you can build dashboards and so on, machine learning and other tools. And this data platform is managed. Again, you're not installing any virtual machines or managing any of that stuff. So I mentioned Cosmos DB, and I wanted to just spend a few more seconds on that because there may be some people here that are not familiar with what it is, and it does have specific applicability to FHIR scenarios. So this is kind of our document database, if you will. So it's not a relational database, but you can store documents in it, and it's a globally distributed, massively scalable database, but where you can also access your data through different APIs. So you can use Mongo API or the DocumentDB API, the native one, or Gremlin, or one of the other ones. So this is a very attractive platform for storing FHIR resources in, and that's also what we use as the backend store for that FHIR server that I just mentioned before, that I'll get back to in a second as well. So this is great. Now you have somewhere you can put your code, and you have somewhere where you can store data. So how do you then deploy a FHIR server into Azure in a way that's automated? And a while back, I made this repository where there's some templates in for deploying well-known FHIR servers, such as FHIR, Vonk, with different backend databases. And this is another advantage of the cloud, is that these are template descriptions of what you would need in terms of services and an automated way of deploying this. So we could just pick one of these templates, and here, for instance, is the template I have in there for FHIR. I have a little description of what you need to do to the source code that's in to the FHIR source code to get it built. But then all you really need to do is you click a button here, and you then deploy the services that you need into Azure. And in this case, this is an app service and a SQL database. So I'm going to show a few screenshots of what this looks like. I will also do some live demoing on the portal here in a second, but just in the interest of time, some of it I'll just screenshot my way through here. So to host this FHIR server, we have a SQL server and a SQL database where the data will live. And then we have an app service, and that's where the code runs. That's where your Java code will run. And then an app service plan, that's the representation of the compute resources that underpin this app service. That's also the scale unit, and that's what you pay for, right? So you can scale this up and scale it down and so on, and similarly with the database. So we can click into this app service here, look at telemetry from this particular application that's running. It has a URL here. You can also put a custom domain name on it. You can click into that, and now you have a FHIR server running. There's nothing particularly spectacular about the FHIR server or the flavor of it that we're running here, but it is now running in a fully managed platform. You don't have any virtual machines to manage. The database is scalable. You can fail over to other regions. You have backup capabilities and so on. And similarly on the front end, you can take advantage of all the enterprise-grade stuff that's in there. So various FHIR servers you can deploy into Azure this way. And then, as I said in the beginning of the presentation, we've also made our own FHIR server. And we call that the Microsoft FHIR server for Azure, and it's available on GitHub as of this week. This is a project that we've been working on for a little bit. But we're now releasing all the code into sort of an open environment. And this is, we wanted to build a FHIR server because we like this community, and we wanted to contribute something back to this that was something more than just symbolically we support FHIR or something like this. This is actually our way of saying, if we wanted to build a FHIR server for running in Azure, this is what the code would look like. And you can take this code and deploy it yourself. And I'll show you how to do that in a second. So it's an open source project. All the development is being done on GitHub, but it's backed by a real engineering team at Microsoft. Several of them are sitting right here, and you can come and chat with us also while we're here. But so the GitHub repository is not somewhere where we push code from time to time or something. That's actually where we do all the development. So you can follow along with it, you can see what's going on, raise issues and so on, and also contribute back yourself. So I'm gonna just switch over to the browser here, and I hope this shows up okay. So this is just the GitHub repository here, and so you can browse through the code, look at all the stuff here. We've written up a little bit of documentation and pointed to some documents here. There's current features that are supported, there's a roadmap, there's links to a demo that I will describe a little bit later on that ties together this FHIR server with other services in Azure, and I'll get back to that in a second. And then we also have deployment instructions here. And in these deployment instructions, there's a little bit of a write-up here of how you would configure the Azure Active Directory components that you need in order to get authentication and authorization to work on this server. We're providing some command line tools for automating that. If you want to, you can also do that through the portal. And then you can deploy the FHIR server, and again, we're providing command line instructions, and you can also do it through the portal. So what I'm simply going to do here is I'm going to click this deploy button, which, if the internet is cooperating, should take me to the Azure portal and take you through the experience of actually deploying our FHIR server. And it's pretty easy, so I'm just gonna do it here. I'm gonna create a resource group. So I'm gonna call this DevDays FHIR server 12, because I was doing 11 this morning. I'm going to deploy this into Western Europe, and then I'm going to, I have to give this one a name, and I should be consistent here. And then you can fill in some other details. For instance, you can provide an app service plan that you have deployed already if you wanted to leverage those resources. And the other thing that you can configure here is the Azure Active Directory details. If you want authentication and authorization done with Azure Active Directory, you would provide the authority and the audience here. If you don't do that, it will simply be deployed without security enabled. The other thing to note here is that we're linking directly to the repository URL here. So what's going to happen when I hit deploy on this is that it's actually going to deploy the required services in order to run this, but also going to pull the code straight from GitHub, build it, and get it up and running for you. So you don't have to do anything in terms of downloading the source code and building it or anything like that. And if you fork the repository and do work on it yourself, you could just link to your own repository in here. And as you update this later on, you can then pull the latest changes and so on. That's part of the app service. So I'm going to just hit go here. Template is going to get validated, and then this deployment is going to start. And this takes a little while to deploy. It takes a couple of minutes to deploy the required services, the app service and the database, and then another few minutes to download the source code, compile it, and deploy it, and so on. And I'm not going to embarrass myself by treading water here while that happens. So I'm going to switch to one that I deployed already, just in the interest of time. So I have one here that I already have up and running, and we can just look at the resources that get deployed with this. So this should now look familiar compared to the happy FHIR scenario I had before. I have an app service where I'm running my code. In this case, it's .NET Core code, but it's the same service that we're using. There's an app service plan. Instead of a SQL server, I now have a Cosmos DB, which is where I store the data. There's a Key Vault, which holds the secret for accessing the database, which is used by the app service. And then we also have something called App Insights. And App Insights is a service in Azure that allows you to collect live telemetry from a running application. And I'll show that in a second. It's kind of one of the things that you get if you deploy this. So you can click into this, and we should see what the URL here is for the server. And I'm going to just copy the URL here, grab a browser window, and maybe get a metadata statement here. So this should give me the capability statement for this FHIR server, and this should look fairly familiar to everybody, hopefully. And then I mentioned that we have this App Insights thing, so we can actually try and see how this works now. So I can connect directly to the running service here and actually see live telemetry from my FHIR server here, if everything works. And it's always a little live demo nerves here, but it should connect pretty quickly here. So now I'm actually connected to the live instance of the FHIR server, and I can refresh here, just get this metadata statement again. I'm just going to hit it a couple of times here so we can see what's going on. And I can go in here, and now you can actually see there's telemetry coming in here live from this service that's running. And I could try and, for instance, get the patient endpoint here. There are no patients in this database, by the way, so that's why this is empty. I can see I get more events coming in here, but then if I try to, say, access a path that doesn't exist, I'll get an error, but that also shows up here now live in the app insights, and I can see that there was an error here. Somebody tried to access an endpoint that doesn't exist, and so on. So these things are features of application insights, and because of the way that we've written the service and the way that we deploy it with the template, these are things that it kind of comes with out of the box. So it's kind of a nice development environment. So I'm going to switch back to my slides just for a little bit, and then we'll go back and look at some more live stuff in a second. But I want to say a little bit about the structure of this FHIR server. I'm not going to walk through the code. It's on GitHub, so you can look at it yourself. But I wanted to point out there are a few different layers in this implementation. And in particular, I wanted to say that the persistence layer is a pluggable module. So in the version that we've put now on GitHub, we have a Cosmos DB provider for this, but you can implement your own if you have some legacy or other data store and you want to use that, but leveraging everything else that's included with this server. You can implement your own persistence provider, and we may also very well bring out others in the future, and it will depend a little bit on sort of the interaction with the community. But obviously, Azure SQL would be something that we're thinking about. So. I just wanted to point out that is something where you could go in and contribute something that works for your specific scenario. Then I want to say a little bit about authentication and how you would actually use this in an application. So if the FHIR server is deployed with Azure Active Directory, it now means that when you access the API, you have to present a token. And a consuming application would then have to authenticate against Azure Active Directory, obtain a token, and present this token when accessing the API. And we then have a role-based access control system that we use to determine whether or not that this token in fact grants you access. And right now, that is based on the claims, on the roles claim in the token, but this will be very soon configurable, so you can decide what particular claim it is that defines the role in your token. And right now, I want to say a little bit about what the state is of this now and where we see it going. And this is more or less, this is an invitation for you guys to give us feedback and tell us what you guys would want in terms of a role-based access control system. But right now, based on the roles that are defined in the token, you can globally grant permissions to read, write, delete, and we also have a hard delete, actually. And you can grant those permissions, but globally on the API. So we're, of course, well aware that that's not going to be sufficient in terms of granularity for what you want to do. So we have plans for implementing something where, on a resource level, based on the filter that applies to the URL that you're trying to access, you can grant specific applications to certain, or specific permissions to do certain actions for certain roles. And just, this sounds very abstract, and hopefully I won't make it worse with this slide, but I just want to give you an idea of what this might look like. So for instance, here in this case, if a consumer of the API has a role patient, and the URL, the FHIR URL they're trying to access is this particular, is basically the patient compartment here, you'd be able to write policies where we, for instance, we search for a patient which has an identifier that corresponds to a certain claim in the token. And if that patient that you're trying to access, in fact, is the same patient as this user that's accessing, we will grant read-write unless certain other conditions apply, and so on and so forth. So you can imagine you can describe quite elaborate role-based access control scenarios with this sorts of, and there would be other functions here that we can do as well. So this is currently being implemented. If you guys have feedback, suggestions, and stuff for this, come and chat with us. We're happy to take input on this, and we're trying to do the best that we can to implement a system that can be used for most applications. That being said, though, we're also well aware that even if we implement most perfect RBAC system for this FHIR server, it won't be suitable for every single need. So there may well be applications that will need to do something custom in terms of access controls and stuff like that. So there are some other tools in Azure that you can then leverage for those scenarios. And one that I want to call out is Azure API Management. So that's basically a layer that you can put on top of your FHIR API and build in a bunch of policies for controlling access, but also doing other things like maybe choosing different backends depending on where the requests are coming on and so on. Azure API Management is part of our integration services. These are all, again, managed platform services. There are no VMs involved, but it sits there together with logic apps, service bus, event grid, and other things that you use to sort of integrate data and implement business flows. In addition to this being a managed platform, there's also been a lot of compliance work done on API management. So for instance, for US government customers, this is FedRAMP High and so on, which are some unique features of API management. But API management in general, it's not just ours, it's sort of similar characteristics on different platforms, but provides in principle at least three different things. One is a gateway that mediates access to the backend API, and this is where you would deploy policies, right? Interpret, the contents of a token that's being presented and decide whether or not you have access to certain endpoints. Redirecting based on where the requests are coming from and so on. That can all be expressed in policies. And policies in Azure API Management are written in a combination of XML and C#, and it's actually quite powerful, even if it's a little daunting in the beginning when you want to get started with it. But you can actually do quite a lot with that. There's also an admin portal where you decide, what endpoints are exposed, what policies apply to what endpoints, and so on. And in our case, that's mostly just the Azure portal, really, where you control all of those things through. And then the final thing that API Management provides is a developer portal where developers can, if you have people that are developing applications against your API, they can come in and browse the APIs, try them out, see what's happening, and so on. I'll illustrate this here in a second. So these are features. The developer portal, for instance, we don't currently have a plan of implementing that as part of the FHIR server. So if you wanted something like that, regardless of the access control stuff, API management may be something that you want to have a look at. Now, there's a few configuration steps to set up Azure API Management. And so to make that a little bit easier for a FHIR endpoint, I made this little service. And if some of you were at the HL7 FHIR roundtable a few months back, I presented this, but I just want to summarize it here. You can actually go right now to aka.ms/FHIR to APIM, and this service is live right now. But what it is, it's a small web application where you can give it the URL of a FHIR server, and it will then take the capability statement of that FHIR server and turn it into a Swagger definition. And it can also serve an Azure Resource Manager template. So those two things in combination, if you send those to the Azure portal, can automate the provisioning of API management and the basic policy set and so on associated with them. So I just want to show a few screenshots of what this looks like. This is the basic layout of the web page here. You can put in a FHIR server URL and just generate the Swagger statement, and that may have utility on its own outside of Azure API Management if you wanted to use that for something else. This tool is also, the code is available on GitHub. You can download that, build it yourself. There's a command line version of it as well. But you can also use this when you actually deploy API management. So again, we have the deploy buttons here, and you would click in, and this would be the similar experience to what you would have when we just deployed the FHIR server before. You can provide a few details here, what you want to call your API management instance, what the FHIR server URL would be, some contact details and so on. Also, other things you can configure here are what resources do you actually want exposed? Do you want everything, or do you only want patient and observation and encounter, say? And also, what interactions do you want to enable? Do you want everything that's defined in the capability statement, or do you only want read access? These are things that you can define here when you deploy the template. And the other stuff that you can provide is OAuth details if you want to enable OAuth on this API. And if you provide those details, it will validate the token coming in, but it will also integrate with the developer portal, as I will show here in a second. So This is what the developer portal looks like when it comes out of the box. This is customizable. You can brand this, change the look and feel of this. It's sort of a content management system, so you can put your own look and feel on this. You can see what APIs are available. And in here, I've deployed this. I've basically put API management in front of the public FHIR server in this case, and I've also configured OAuth on this. So I can click into this API and I can see what endpoints are available here, and also what things I can search, and there's documentation and how you would call this endpoint in different programming languages and so on. It's all built into the API Manager's developer portal. You can try these out, and in this case here, because I'd configured OAuth, but I had not actually requested a token yet, I get an unauthorized access. But the OAuth configuration is built into the developer portal so that you can pick it from this drop-down box here, and it would then take the developer through the experience of signing in, getting a token as you would on behalf of a user, which would then can be included in the request, passed on to API management, and then you should get access to the API. So this whole experience, securing your API with OAuth and having that experience included into the developer portal is possible with API management, and that little tool that I showed you kind of automates the deployment of it. So I want to update my office here. I should probably wait with that a little bit. The tool that I made there for deploying this automatically is kind of a way for you to get started. It will very quickly get you up and running so that you have API management running for your FHIR API, but you'd probably then want to change some things in the policies and stuff to suit your need. But it's a place to get started, and so if you have questions about that afterwards, I'm also happy to take those questions out at the table there. So towards the end of the presentation here, I just want to talk a little bit about this demo scenario that we've put together. And basically with the things that we've shown so far, you now have the ability to deploy a FHIR server, whether it's FHIR or it's our FHIR server, but into a set of managed services. You also have the ability to configure something like API management if you want to control access to it. So you now have a setup where you can write applications, FHIR applications, patient apps, and so on, that use your FHIR services in Azure. But you may want to do other things with that data once it's in there. You may want to export it, do analytics on it, do machine learning, and so on. So we wanted to put a little bit of a scenario together with doing that with some platform services in Azure. And there's one tool that I think is particularly useful. It's called Azure Data Factory. And this is basically our sort of enterprise data integration service. There's a number of connectors to different types of cloud storage and databases and so on. You can connect to these databases or cloud storage, whether it's in our cloud or other clouds, pull data in, then have the data go through various transformation processes and ultimately end up in some other form. So you could have a bunch of JSON files in blob storage. It gets ingested, it goes into a SQL server, and then ultimately that ends up driving dashboards or machine learning or some other thing like that. And so there are a number of tools available in this platform, so we thought it made sense to see if we could pull FHIR data in there so that you could work with the FHIR data in there, but also you may want to integrate with other data sources that you have in your organization, and then you would kind of have it all in one place. So I put together this little demo here, and you can find there's a link to it at the front page of the FHIR server's README file. The URL is also here. This scenario you can deploy into Azure it takes a minute to start the deployment. Probably takes 10 minutes until it's all deployed. And then you have this little toy scenario that I'm gonna walk you through here. So a number of things will get deployed in this scenario. You'll have the Microsoft FHIR server for Azure deployed, which is basically a web app with a backend Cosmos DB and the FHIR server code deployed in there. We then deploy a reservoir of some synthetic patients. They're not actually at this point ingested into the FHIR server. The way that we do this is I run Synthia in a Docker container as part of the deployment, and that generates patients and puts them into a storage account. So they just sit there. They haven't been ingested into the FHIR server yet. Then there's a very simple web client for accessing the FHIR server and also interacting with this reservoir, and I'll show it in a second. And the FHIR client here is configured with Azure Active Directory. And it's actually done in a way that it's we're leveraging the app services capability of doing Azure Active Directory authentication. So there's nothing specific in the code that does the authentication and the authorization. It's actually done as part of the app service. So you could use that as a template for putting in an application that was written in a different language, Python or whatever, and you can access the token that you would need to access the FHIR store simply through a header. And you can see how all of that is done in the code, and we're also happy to walk you through it out at the table. Then we have this export pipeline, which is a data factory instance, and there's also a batch queue associated with this, because this batch queue is used to do the querying jobs against the FHIR server so that we can pull large amounts of data out of the FHIR server. And it basically orchestrates a flow where data goes from the FHIR server, goes into ND-JSON format in blob storage, then it gets ingested from there and goes into a SQL server, and then we do some combination of this data. So I'm gonna just show you this here, because that's probably easiest. So here's the FHIR client here. It's very simple. My apologies for my web design here. It's not, but you guys can take it as homework to pretty it up or something. We're happy to take pull requests. But basically, the FHIR client here just explains the scenario here. There's also a GitHub link to the actual code. You can click here, there's this about me here. It actually tells you who's signed in here and what's the FHIR server URL for this particular scenario, and then there's a token here. So this actually is all the information that you needed if you wanted to interact with your FHIR server on the command line, or you wanted to use Postman or something like that. So that's just, we wanted to make that available if you wanted to interact with your FHIR server, not with this client. And then there you can query what patients are on this database. This is not very elaborate, but we can click into a patient here, and what we should see is like all the encounters and observations for this patient, and you can look at the FHIR resources for these different observations and so on. So it's just a way for you to look at what's in the FHIR server. And then we have this patient reservoir here, where we have a number of patients that have not yet been ingested into the FHIR server. So if you spin this scenario up from scratch, there will be no patients in the FHIR server, but there will be some in the reservoir, and then you can click import and import these patients in. It may take a few seconds to import these, because there may be, you may hit a patient with thousands of resources associated with them, and it takes a little while to import those in. So that's the basic FHIR client, and we have some laptops out there set up where you can play with this. Then the other, maybe more interesting part of this is the data factory pipeline. So data factory has its own user interface, and the way that you get to it is you go to your demo environment here, and we can actually see all the resources that have been deployed here. So this is the FHIR server, the SQL database that we'll be using in a second, the client, all the other stuff. Again, these are all managed services. There are no virtual machines in this scenario here. But you can click into the data factory here and get to the data factory UI through this button here, and I'm just going to switch over to it here. And this is kind of the pipeline. This pipeline, by the way, gets configured automatically as part of the template deployment there. Every step that's in here, every statement, export, and so on, it all gets configured automatically. So there's no manual configuration that you need to do. But you may want to, once you start playing with it, you probably want to make changes to it to support whatever scenario you want to explore. This data factory pipeline does a few different things. It actually pulls down a custom job that I've created for querying the FHIR server. It queries directly on the REST API, so you can in principle use this with any FHIR server. I mean, we're using it now with the Microsoft FHIR server for Azure, but in principle you could do this against your own FHIR server or whatever is your preference. So it pulls down this custom job, and then it does a number of exports here, and sort of arbitrarily I'm exporting the patient resources, all weight measurements and all height measurements of these patients. We then run an import job into a SQL server here, and then finally we do a join and combine all the data that's available. And we should actually be able to go in and see the data that's available in this. So this is what we end up with. There's patient ID, age, height, weight, latitude, and longitude. So it's not terribly refined, but it does show the combination of data across multiple resources within the FHIR store. And then once you have that enabled, you can of course use this database for say a dashboard. So here I am in Power BI, and I've cheated a little bit and connected it to this database in advance. So then we could try and plot some of this information here, latitude, longitude, and maybe say patient weight. And I'm just gonna do it like this. So this is, all the patients are in Massachusetts, as they always are with Cynthia, or not always, but out of the box they're in Massachusetts, right? But you can see the patients that are in this database here, and the color of the dots here is now indicates the patient weight. So you can see the dark ones here. Heavy patient there, 133 kilos, and over here it's 44 or something like that, right? So we've now taken it all the way from setting up a FHIR server in Azure, which could be, as I said, a number of different FHIR servers will run in Azure in these managed services, but in this case it's the Microsoft FHIR server for Azure. We've set it up so that we've configured authentication, we've hooked up a client to it, we talked about how you can set up API management on it. If you want to create more elaborate policies or enable a developer portal on this. And then we've also shown that you can extract data from this using managed tools again and get them into a form where you can drive dashboards or machine learning or whatever is your scenario that you want to support. And again, all of this is done without ever spinning up a virtual machine or patching an operating system or doing any of those things. So I think this sort of brings me to the end of my presentation so that I have time for a few questions. I just want to make sure that you have the URL again for the FHIR server. Here's my email address if you have questions or anything like that. Don't hesitate to reach out. We have laptops out here at our table where you can come and play with this scenario. If you want to come with your own laptop and deploy it into your own subscription, we're happy to help with that. If you want to just deploy the FHIR server, we're also happy to help with that, or any questions or suggestions or anything that you have. We have these three gentlemen here in the front row are all my colleagues from the team. So with that, thank you for your attention and look forward to chatting with you. Thank you.
Hi, that was great. Is there a way to ingest like flat files or JSON files into the FHIR server? You showed the bulk or the extract.
So there's nothing built into the FHIR server right now, but I do have a tool for it that I can point to. But we have nothing built into the FHIR server right now. But it's obviously something that we're thinking about and planning for you.
With your persistence layer, is there any chance to do a dual write, one in a relational database and the other one maybe in Elasticsearch?
Yeah, theoretically, of course, yeah. It's not something we've implemented right now. I'd have to think about that a little bit. I mean, you could write your own persistence provider that does that, right? I don't think we have considered actually supporting multiple in parallel without kind of building that into a single persistence provider, but I'll take a note and think about it. Yeah.
How compatible is Azure authentication with Smart on FHIR?
Yeah, it's a good question. So this is really a question about the identity provider, right, and the flow around that. And I mean, I'm gonna be pretty honest up here and say there are some gaps, and we're trying to work through those. So part of what we're doing here in Microsoft Healthcare with this whole effort is expose to ourselves, what those gaps might be, learn, figure out how we do it right. And so this is part of an, if you will, internal process where we get better at doing this. In the meantime, we have some plans for building a proxy into the FHIR server itself that kind of does some translation across those gaps so that we will be able to use Smart on FHIR applications straight against the FHIR server here. But so that's the short-term plan. The longer-term plan is trying to get some fixes and things done in Azure Active Directory to make it more compatible. So I don't know if that answers your question. Yeah, it's a little bit of a dodge, but I would hope yeah.
So two quick questions. First of all, thank you a lot. This is really awesome, really awesome. First quick question, can you say anything about performance? And especially I saw on your FHIR server, like I assume that's related to the FHIR server because of course it depends on the backend, but I saw for search, you don't support chained params, which are tricky, and especially getting them performant. So in general, if you can say something about performance. And the other general question, because you demonstrated a bunch of analytics, like to the right kind of, which is great. And I think we have found that doing analytics on FHIR is kind of tricky because the data model is not necessarily that like easy.
Yeah.
So can you say something about that, like beyond the infrastructure?
Yeah. So, okay, so two questions basically, or three questions really, performance and in the context of chained searches as well, and then the difficulties with doing analytics using FHIR. Oh, how much time have I got? Okay, so in terms of performance, I'm just going to be honest and say we don't have a huge amount of data right now on very large data sets in this particular service here. So it's something that we're busy at work collecting, measuring, and we would very much encourage any feedback from anybody that has experiences, especially if there are particular pain points. So I don't have like numbers for you that I can give you. I could just say that it's something that we're very focused on getting right, and hopefully we have already. But we're also aware that we'll probably need to do some optimization. That's part of the process that we're in. Chain searches we don't support right now, and it sort of goes back to the persistence layer, right? It's not super easy to do these types of searches in that type of database, which is why we're also exploring other persistence layers. So a relational database may make more sense to support those things, but then there are other trade-offs with that, right? So it may well be that becomes something that you decide, do you pick one persistence provider and get certain features out of that, or do you pick another one and enable something like chain searches? And I think we're in a phase of exploring this and figuring out how to do that right. Can we have it all in one persistence provider? Do we need to provide different ones? So again, that's not really an answer. I'm just telling you where we are with it. And then final thing was about analytics and the difficulty with doing that. I mean, we really, just going to be honest, we struggle with this and try to figure out how to do it. I think our path is going to be trying to make the integration with Data Factory a little, use that as a layer where we can hide some of these things and enable easier extraction and flattening out of data and joining data and so on. And but we haven't settled on how we're going to do it, but that's kind of the direction that we're working in. So 3 non-answers to your 3 questions. Apologies. Yeah. Okay. Free text search. I'm looking at Brendan right here. Do we support that right now? So maybe we can show you through what we have at the table, and we can sort of work through whether your scenario is supported. Yeah. Okay. Anybody else? Otherwise, come hang out with us, and we're happy to get some feedback. Thank you.